The entry problem which building word across context coherence matrix. Using the same problem, same process, we have used the problem one with symmetrical words k is equal to 2 each side. This is not causing sentence boundaries and diagonal set to 0. So first look at the process. Uh, we have used the same process to solve n1 problem. Here uh, it represents the hot limitations also. So part A, the question is to construct complete coherences matrices of popularity 15 plus 15. So matrix represented is like this here. So we have taken all unique words in the vocabulary as rows and also columns. We set the table based on human occurrence within this context window. So table besides each other in single sentence, then we will assign otherwise zero. So based on the same rule, we have built this whole matrix. And second question is that write down the vector and vectorial representation word systems. So using this matrix, we require rows. So we have represent question B also, which same user time loss. So we can see here user and time loss. First part C, that cosine similarity for system users. So here first dot product of the systems and user calculated first. When we look at the table, the system and users also have non-zero and simultaneously interface also management. So when we watch all three, get the dot products, and there we can calculate magnitude of systems by looking how many ones are, how many zeros, non-zeros occurred in the same systems. Now by calculating sum of square rootings. Here we when magnitude vectors so that we can calculate the cosine similarity by using same formula. By magnitude of respect to vectors, so the system can use pair we got dot product cosine similarity as 0.5303. Similarity we can calculate by any pair. For example, here the system time. We already know magnitude of systems, and for time we can calculate the by looking at the rows and non-zeros in a table. And also we can calculate the dot product by looking simultaneously non-zero values for both vectors. For system that and the time we got 0.3086. So cosine similarity. So here what happens is that base system and user judge more similarity than base system and time, because 0.530 is higher than the 0.308. So this agrees the linguistic institution this is in system not appear to word together shared context like this. So words interface magnet management comes systems user, but with system and time only response is a common word. So similarity gradually increases when compared to the system and user one. Next question is k is equal to recombinant matrices k is equal to 1 and k is equal to 2. Calculate the density. Here density means, so when percentage of non-zero entries in the matrix, so first we can calculate the total possibility entries such a vocabulary whole square, this is 2 to 5. Matrix density formula we have written non-zero entries by vocabulary square into 100 is equal to for k is equal to 1 here. Then immediately after, for example, if you look at the sentence one for human and immediate next word mission. So neighbor of the human would be mission and there is no before word. So the neighbor of human context and word of human is mission. So equal k is equal to 1. Similarity, all we can return the space and we get almost 18 unique waves at distance 1. Since matrix similarity is B and we also written as a B and AB. So when we will have non-zero values, BA will also non-zero values. So the not all zero and this would be 18 into 2 and 26. Density will be collected with the formula 36 by 225 in the 100. So when we have also the formula that is 6 by 225 into 100 which 16%, k is equal to 2. We verify the matrix representatives is also calculated. How many non-zero entries are there which occurs 66 and the percentage would be 29.3733. So k is equal to 4. Similar way, we can first unique pairs for all sentences when context window k is equal to 4 multiply. We have 98 non-zeros and k equal to 4. Similar way, we first write unique pairs from all the sentences with the context window k equal to 4 and can apply with 2. So we have 98 non-zero entries and the density would be 4356. Here we estimate the trade-off between small large window. For a small window that is k equal to 1, it captures most immediate cynic coherence that is adjacent words that form tight grammatically units. And the matrix is space which means 16% density and which means almost two cells equal to 0. Representation are noise for infrequent words but relationships are more precious are local. Large windows for k equal to 4 captures both optical coherences words appearing anywhere within a neighborhood even without a direct cynetic relations. The matrix become denser gives much 43% uh, that more than triple of k equal to 1 window. So here distance means less meaningful related words. Shade poker diluting relation representation patience for the last questions and is stop word. The stop word for the stop word, so we how can it affect and what the solution to it stop. So when we observe the matrix the row for the row, the most non-zero entries, whole matrix becomes a common word. It can occur with any other word and it does not really mean semantic relationship between. In the these the rows. And so to stop that we can apply solutions that is solution 1 drop very frequent words that is remove 4 column. When we remove we can have 14 rows 14 columns. So for this, we can say that we can missions. Uh, we can say how related because for and we can only interface the computer. So related because the middle word for not there is stop them. Next solution two is that thresholding medium value. So since the matrix and is original matrix. So 2's responses time and time responding traces are equal to leaves the matrix unchanged. Even anti-versional k equals to 2. Matrix already satisfying less than equal. So this is expected because this is small corpus and common magnitude never grow larger enough to equal to 2. For big corpus this can be huge effect.